Okay, these are your notes for exponential and logarithmic functions, chapter 7.3. First of all, logarithms. Logarithm functions are inverses of exponential functions. Okay? They are reflected around the line y equals x, which is denoted by this dashed blue line right here. All right? The first thing I chose were these x's here. -2, -1, 0, 1, and 2. And what I did is I put these x's right here in place of that x. And then f of x obviously is the y value. So when I plug in -2, that actually comes out to be 1/9, which is 0.111 repeating. 3 to the -1 happens to be 1/3, which is 0.3 repeating. Anything to the 0 power is 1. 3 to the first power is 3. And 3 squared is 9. What I did next was I plotted these points here accordingly to according to what my table said, and then I connected them. I then, now notice on this next one, this denotes inverse. So f to the -1 power denotes an inverse. So only thing I had to do was switch the x and the y. So now the y value over here now becomes the x. All right, these y values now become the x. These x values now become the y. All right, so I have 0.1 repeating. So at 0.1, -2, that dot's there. At 1/3, -1, that dot's there. At 1, 0, 2, 1, and at 9, 2. And I connected those points to give me the inverse. Notice that these two are reflections. So this is the line of reflection. Okay. All right, so the two things we're going to talk about today are logarithmic form. So y equals log base b of x. So y is equal to log base b of x. That's how you read that. Y equals log base b of x. And I want you to notice that this b right here is dropped down a little bit. It's a subscript. And the word log and x are all on the same line. In exponential form, x is equal to base b to the power of y. Okay? Base b to the power of y. Now, there are some common notes that you need to know, and you need to really pay attention to these. Common logs have a base of 10. Common logs have a base of 10. In other words, if there's no base, if no base is listed, it's an automatic 10. Just like when we have the square root, when you have like the square root of x, that means x to the 1/2 power. Or if you just have a variable x, that means to the power of 1. So there's some things that are understood. One of the examples, if I give you log of 3, well, what that really means is log base 10 of 3. So notice that there's no base here. So it's understood that it's a base 10. It's understood that it's a base 10. And the way we read it is log base 10 of 3, or simply you can just say log 3. Now, there's another thing called natural logs. Natural logs basically happen naturally. And we use a letter called the letter E, or they have a base of E. And we'll explore this a little more, but E actually is a number. It's a number that occurs naturally in nature. All right? So, if no base is listed, it means base E. So instead of using log, natural logs use the abbreviation, and I believe that's 2B's, isn't it? I'm not sure. Anyway, natural log uses the abbreviation LN. So whenever you see LN for, that naturally means or automatically means base E. Okay, so what we would do is I could actually write it, and sometimes I would prefer you to write it ln, so natural log of 4 means log base E of 4. So you can either write it like this, or you can actually write it like this. Either way is fine. Okay? So quickly, as we explained earlier, I'm going to do my little I heart logs. All right, I'm going to do that for every single one of these. And notice, even though I'm the teacher, I still want to make sure that I'm doing it correctly. So I did a heart for every single one of these, even if there's a base or not. So base 5, so it's log base 5 of x equals y. So 5 to the y power equals x. Down here, this is now this is a base e, so that's really a natural log. So this is e to the negative 3 power is equal to b. The next two, 8 to the power of y equals x. 3 to the power of c equals 5. A to the power of 5 equals 4. And 2 to the power of 3 equals 8. And notice, if you do 2 to the third power, 8 does equal 8, and it does work out. Okay? On the back, on this one, now notice, there is no base 10, so I automatically wrote one in. So it's log h equals 3. Well, since there was no base, I can assume that it's base 10. So 10 to the third power is h. And actually, 10 to the third power is 1,000. So if I asked you to evaluate it, you could just write that. Natural log of 3. So now notice, this is a natural log. I rewrote it as log base e of 3 equals a. Well, that simply is going to be e to the power of a equals 3. E to the power of a equals 3. Let me move that over so you can see that. All right. Now, this next little section, we're going to change from exponential form to log form. So earlier we went from log form to exponential. Now we're going in reverse. So 1.2 to the power of 3 equals m. Using my heart, log base 1.2 of m is equal to 3. Log base a of 24 is equal to 4. Over here, this is a natural log. So as soon as I see the e, immediately I think, oh, okay, well, I can either write it as log base e of 9 equals b. And because this is a natural log, I simply can just write ln 9, meaning natural log of 9 is equal to b. And then finally, c is equal to 10k. Well, when I first did it, you can probably see how I kind of marked some things out and I had to white over it. I actually rewrote this as 10 to the power of k equals c because I'm used to writing it like this. So I wrote it to where it looks familiar to myself. And then 10 to the power of c, I'm sorry, log base 10 of c is equal to k. So I can write it either one of these. I don't have to put the 10 there, but normally I do just so for my peace of mind. All right. Now, here are 3 properties you definitely need to know. These 3 properties are pretty vital today. Okay? Now, the property log base b of 1 equals 0. Well, why is this so? Because if you do I heart logs, or if you do b to the 0 power is 1, anything to the 0 power is 1. So we just proved that using exponential form. And why is log base b of b equal to 1? Well, if you again put it in exponential form, this becomes b to the first power equals b. And anything to the power of 1 is itself. And then finally, log base b of b to the r power is equal to r. Well, why is this equal to r? Well, if you start off with the log base b of b to the r power equals this little question mark. Well, as we've done in previous problems or on your past homework, if I do I heart log, so b to the power of this blank is equal to b to the r power. And if you rewrite it as such, b to this question mark equals b to the r. Well, in order for these to look the same, this blank has to be an r, and that is why it is equal to r right there. So with knowing that, let's move over here. So if I have a log base 3 to the 1 power, anything, whatever the base is, it doesn't matter what the base is. If it's log base of 1, it's always a 0. So this could be base 10, this could be natural log, this is base 3. If it's log base 10 of 1, it's always going to equal 0 because anything to the 0 power is 1. Now this is the same rule, or same concept as we just learned. 3 to the power of 1 is 3. 10 to the power of 1 is 10. E to the power of 1 is E. And then finally, as we just showed in right here, if you have a log of the same base of the same number, whatever the answer is going to be whatever that power is. So the answer here is this power here, 3, 3, and again, -2. So notice it turned out to be these numbers here was our answers. Okay? And then on the work down below, I simply just went through. So I just started recognizing some of these properties. Okay? All right, so I have log base 2 of 1. Well, I know that's a 0. Log base 8 of 8. Well, that's 1. Okay, let me just do the first column here. 2 to the blank. Notice I put a blank power here. So 2 to the blank power is 8. Well, I know that blank power has to be a 3. 1/3 to the blank power is 9. Well, first of all, I need a negative number to flip it up. And then to square it gives me 9. So that blank has to be a -2. And because this is a natural log, remember, natural log base E of E, well, it's going to be this answer right here of 2. Let's go to this column here. I've already done B, so let's look at this one. Now, I rewrote this square root of 10 as 10 to the 1/2. So 10 to the blank power is equal to 10 to the 1/2. Well, in order for these to look the same, this has to be a 1/2. And 10 to the blank power of 1,000, I rewrote 1,000 as 10 to the power of 3. In order for these to look the same, that blank has to be a 3. And then finally, the last thing. Notice log base 3 of a negative number. This is not possible. So anytime you see a negative number in this spot right here, you just write not possible because you can't take a number to a power and get a negative. And that is today's notes and lesson.